Hi everybody. In today's video, you're going to learn I'm going to show you how to turn a repeating decimal into a fraction. So let me start with this example. Here's a typical or a very simple repeating decimal. We write that bar over it indicating that it's actually this number, 0.444, dot, dot, dot. 4 is going on forever. Okay, so here's how we do it. The first thing you do is you write a let statement. Let x equal 0.44. We're going to use this version. Then I'm going to write an equation, this equation. Now I'm going to multiply both sides by 10. Multiply both sides by 10. So I get 10x equals 4.444 repeating. Now I'm going to subtract the same value from each side, but it's going to look different. On this side I'm going to subtract x. This side I'm going to subtract the repeating part. So now look what happens. This side, 10x minus 1x is 9. And here the repeating parts cancel. 0.4 repeating minus 0.4 repeating is 0. So I'm left with 4. And then divide both sides by 9, and x equals 4/9. So 0.4 repeating is equal to 4/9. And you can use your calculator to check that answer. That's the best way, I think, to check them. Okay, let me show you another example. This example, I'll show you a negative one. So let's do negative 0.5 repeating. So my let statement is let x equal negative 0.555 dot, dot, dot. I write my equation, and I start solving. Because there is one digit repeating, I'm going to multiply both sides by 10. So this turns into 10x. This turns into negative 5.555 repeating. Subtract x here. Subtract the repeating part here. Now be careful with that negative. So here, 9x. Now let's concentrate over here. Well, subtracting a negative is the same as adding the opposite. So it turns into add negative 5. So the repeating part's negative 5 repeating plus positive 5 repeating cancels, and I'm left with negative 5. Divide by 9. So x is negative 5/9. That's all. Okay, the next one I want to show you is when we have two digits repeating. Two digits. So let's say we have 0.23 repeating. So let x equal 0.23, 23, 23. So it's 23 repeating. We're going to this time multiply because two digits repeat. Recall the last one digit repeated, we multiplied by 10. Two digits repeat, some of you already guessed it. We multiply by 100. So it becomes this. 2, 3 repeating, 2, 3 repeating, 2, 3 repeating, dot, dot, dot. Subtract x, subtract the repeating part. Like so. 99x equals 23. So x equals 23 over 99. Okay? All right, now watch this one. Let's say this time we have 0.23, the one we just did, except this time just the 3 repeats. So I'm going to write this let statement, let x equal, I'll define x as equal to this, just the 3 repeating. I'll write my equation and get started with my solve. Multiply, only 1 digit repeats, so we multiply by 10. 10x, 2.333. Subtract x here, subtract 0.233 ... 10 minus 1 is 9x. Now look closely here, that from this point on, from the 3 here, forever, matches up with the 3 here, forever. These cancel, but I'm left with 3 minus 2, which is 2.1. But the repeating part is gone. It's a little trickier. So now, divide by 9. That's not a simplified fraction. So what I'm going to do is get rid of the decimal, make it 21 over 90, and then I'll divide by 3 and divide by 3. So 0.23 with the 3 repeating is equal to 7/30. Okay? Last one I want to show you is a mixed number. So let's use a simple one. 1.25 and the 25 repeats. I have 2 repeating digits. So let x equal 1.252525 ... Write my equation, 1.252525 ... 2 digits repeat, that means multiply by 100. So now here I would have 125.252525 repeating. Subtract x, subtract 1.252525 repeating. 99x equals 124. Again, the repeating parts cancel. That's the whole objective. Divide both sides by 99. And that's your answer. Surprisingly, this is not divisible by 3 because 1 plus 2 is 3 plus 4 is 7. The sum of the digits is not a multiple of 3. We could turn it into a mixed number. It's 1 and 25/99. Okay, good luck.